Assalamualaikum and hi. My name is Abdul Muiz bin Muhammad Nasir. My metric number is AE180006. Alright, today we will present about the exercise 7, which is open loop and closed position control system. So I will start to present about the first activity, which is open loop position control. So first, the instruction asks to construct the block diagram in figure 3.4 using MATLAB Simulink. So this is figure 3.4, which is open loop position control, and this also they have parameters, position control parameters value in table 3.1 here. And number 2 is key in all parameter values into the Simulink block. So for the first step, I need to design the circuit in the in the MATLAB Simulink here. So here is the input angle, and this is the potentiometer gain. This is the input voltage, and this is the alternator gain. This is the electrical part. This is the mechanical part. This is the integrator, and this is the shaft motor position. So then for the next step, number 3 is check block Simulink by key in input angle value is 1 and the alternator gain value is 1. And if input voltage and shaft motor position display shows the value, its main block diagram is a function. So I try to edit here. They have already number 1, so I don't need to edit. And the gain also number 1, so we just click run and see. Alright, the input voltage and shaft motor position have displayed the number, so it means the block diagram, the system that are in the good condition. And the next step is increase step-by-step value of input angle from 0 until 10 and set alternator gain 0. Observe that shaft motor position display and what happened to the system. So I need to edit this input angle from 0 until 10. So we choose one number which is 10, then alternator gain is 0. So we edit this number gain is 0, and we click run. So if we can see that just input voltage have displayed the number 6.111, and the shaft motor position get the 0 values here. And for the next step is increase the step-by-step alternator gain from 0 until 10 and set the input angle 0. Observe the shaft motor position display and what happened to the system. So I just change input angle equal to 0 and the alternator gain from 0 until 10. So I choose the one number, I choose the 10 number of 10. Wait. So we click run and we see what happened. So when the alternator gain change the number 10, the input voltage the display 0 values, and the shaft motor position also display the 0 values. And so after that, the last step is set the input angle 5, 10 and 360, positive for potentiometer clockwise and negative for anti-clockwise, and fill in the result into table 3.2. So this is the result table 3.2. The instruction ask me to set the input angle to 5, 10 and 360. So I starting with the 5 and positive for the clockwise and negative to the anti-clockwise, so alternator gain is 1. The table instruction also starting with the value of 1, and we click OK. We see what happens. We see the result to the so the result show input voltage is 3.056 and the shaft motor position is 58.64. Alright, after that, this is in the clockwise, so positive. In the anti-clockwise, we just change the negative value, and then the alternator gain is also 1 based on the table. So we click run, the input voltage we get the value negative 3.6056 and the shaft motor position is negative 58.64. Right, so after that we just follow the instruction for the clockwise, the value of 5, negative 5, in the and alternator gain is 5, and then input angle 360 and negative 360 for anti-clockwise, and alternator gain is 8 and 8. So that's all from me for first activity. Thank you. Bye bye.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Wafi Takyuddin bin Usud, and for this particular lab 7, which is closed loop position control, I will explain about the activity 2, which is to construct the closed loop position control as shown in the lab sheet. So I have constructed the block diagram using the software that required, which is using the MATLAB Simulink, and I already key in all parameters value in the Simulink block as requested, and I have checked the block Simulink by keying the input angle value 1 and the alternator 1, and also the input voltage shown, which is the input voltage and the shaft motor position will show value, means that the circuit is function. So it is proven that the circuit is fully functional, and then I will go to the next activity, which is put the control input angle from 10 to 0, which I got the shaft motor position, all the value from 0 to 10 of the input angle, I get the value is all 0 as shown in this particular table that I have constructed. So this is shaft motor position, the value of shaft motor position, and the fifth is the same as before, just vice versa, the value, which is alternator gain 0 to 10 and the input angle 0, and also get the same shaft motor position, the value of them is 0. And for the sixth activity, I will explain about the potential clockwise, which is the positive. So first and foremost, I will put the value. The first value is 5, which is the input angle 5, and the alternator gain is 1. So we will run it first, and we got the input value 3.056, the output voltage 2.4, and the shaft motor position 3.927. And the second one for the clockwise is the input angle is 150, then the alternator gain is 5. So we will run, and this is the value. The input angle is 91.67, the output voltage is 84.61, and shaft motor 138.5. And for the last clockwise is the input angle is 360, and the alternator gain is 8. So clockwise means that all the value of input angle and alternator gain are positive. So we will run, and the input voltage we get a 220, output voltage 119.0.6, and the shaft motor position with the value is 311.9. Okay, that's all for the activity 2. Thank you.
Assalamualaikum, my name is Amir Aiman bin Razalini. Today I would like to present our circuit for activity 2, where the activity 2 is closed loop position control, and my part is just make a anti-clockwise of the operation. Okay, this is our simulation circuit. Okay, to get the value of the input voltage, output voltage, and the shaft motor position, we just select this alternator gain. We just select 1, 5 and 8. Okay, and the input angle we select negative 5 degree, negative 150, and the last one is negative 360. Okay, now the input angle is negative 5 and the alternator gain is 1. Okay, so I run. Okay, and we get the value of input voltage negative 3.056, and for the output voltage we get negative 2.4 for the anti-clockwise, and the last one is shaft motor position, we get negative 3.927. Okay, that's all for anti-clockwise. Thank you.